Hi there, this is Penelope. This is the beginning questions, the first question in section C of the trimester 2 2018 exam, question 9. Now let's have a look at this on the second page. This is what you absolutely need to realise. You only do 2 of these questions, not 4. There are 4 there for you to choose, but you're only going to choose one of them out of section C. They are application questions, so you need to be able to read the question. So you've got a dump truck, cute little picture, costs V squared over $25 an hour to run. V is the speed, kilometres per hour, and other costs are $100 per hour regardless of speed. And it just says, just so that you don't get worried, the negligible variation in speed as it's going along. First question says, write down an expression for the cost per hour. So cost per hour, and it tells you what to call it. It says call it C. So it's going to be this part of the cost first, and then it's going to have the extra cost of $100. You probably won't put the $100 in because the cost will be in dollars. So that's part A. Part B, now the total cost is going to be the cost per hour. So whatever you call it, total cost, it says to call it K. So K is going to be this cost per hour, which was C, times T, which is the number of hours. So it's going to be V squared over 25 plus 100 times T. Part C says find an expression for the time it takes to travel 1 kilometre. And we can just use 1 because it talks about kilometres per hour. So V is going to be your distance over your time. We know that the distance is 1 kilometre over the time. So now we've got a statement that says V equals 1 over T. So T equals 1 over V. Part D says show that the cost for the truck to travel 1 kilometre is given by K equals V over 25 plus 100 over V. Okay, we know what K is. K is, absolutely, that's okay, V squared over 25 plus 100 times T. But we also know what T is because T is 1 over V. So it's V squared over 25 plus 100 times 1 over V, which comes down to exactly what they say, V over 25 plus 100 over V. Part E says find the speed that minimises the costs. Okay, that's going to be the derivative. So the derivative of V over 25 is going to be 1 over 25, it's going to be a 25th, minus the derivative of 100 over V, which would be 100 over V squared. That's got to equal 0 for the min or the max. So swap it around and that'll give you that V squared equals 2,500, so that V equals 50 kilometres per hour. I would like you then to prove that that is the case by looking at the second derivative and proving that it is a minimum by finding that the second derivative is positive at that speed there.